Solving multi-step equations, lesson 8 notes. Continuing with the 3 types of solutions. Now we're going to talk about no solution. So let's take a look at the example. All right, I'm going to do the distributive property. So 2 times 3m would give me 6m. And 2 times 1 would get me positive 2. And then I would just bring the negative 4m down. Equal sign. 2 times m would give me 2m, and 2 times 2 would give me positive 4. All right, combine like terms. So I have 6m here, and negative 4m. And then on the right side, there's really nothing to combine here. So I'll just end up bringing the right side down. All right, so 6m minus 4m would give me 2m. Bring down the plus 2 equals 2m plus 4. So again, that's where if you're doing these problems, you would stop right there. All right, I want you to see, what's different with this problem than the problem up here. What was the first thing I told you to look at for? I told you to look at the variable terms first. Well, up in the one solution problem, we had 4z and 2z. The variable terms were different. But if you look at this one, I have a 2m and a 2m. So in this case, the variable terms are the same. So once you look at their variable terms, if they are the same, then you have to move to the constant terms. And in this case, the constant terms are different. So for no solution problems, your variable terms will be the same, but your constant terms will be different. So let me go a little bit farther with this and show you why it is a no solution problem. So I would subtract 2m from both sides. And I would subtract 2 from both sides. By doing that, you'll see that technically they both would cancel out. And so would this, meaning that there is nothing left on this side of the equation. So on this side of the equation, you would have a 0. But on the other side of the equation, 4 minus 2 is 2. Well, they are not equal to one another. That's why it is a no solution. 0 cannot equal 2. That makes this a no solution problem. So once again, when you do these problems, you will stop at this step right here, and you will examine the variable terms first. I notice that my variable terms are the same, but my constant terms are different. So for, again, no solution problems, variable terms are the same, but constant terms are different. Pause your video and write that down. Okay, so once again, like I said for the top problem, all this stuff that's underneath, you won't have to do it. You will stop where I have it highlighted. You'll do just the first 2 steps. You'll do the distributive property, and you will combine like terms, and you will stop there. All right, so let's write down some examples of what you will look for no solution problems. Let's start with our highlighted part. So that would be 2m plus 2 equals 2m plus 4. Variable terms the same, but your constant terms different. One that often confuses students is one that would look like this. Y plus 6 equals y minus 6. They want to think that both the variable terms and the constant terms are the same, but that's a positive 6 and a negative 6, so the variable terms are different. Another example might be 3m plus 4 equals 3m. So yes, there's no constant term on this side, but when there's no constant term, that means the constant is 0. So the variable terms are the same here, but the constant terms would be different. Another one, how about if you continue to the problem and you got two numbers that are not equal to one another? For example, we have the 0 does not equal 2. Or you might get 6 does not equal 3. Or even 6 does not equal negative 6. So once again, if it is a no solution problem, your variable terms will be the same, but your constant terms will be different. In a one solution problem, the variable terms are different. So up here, variable terms are different, automatically one solution. Variable terms are the same, but constants are different, no solution. All right, if you have any questions on no solution problems, please do not hesitate to ask. Also, please make sure you have everything written down.